Hello everyone. This video introduces how LoRa software controls the C-3200 to test the transmitter characteristics of the DUT in the non-signal test mode. First, the connection of the hardware. First, connect the C-1201 and DUT control cables. The I/O pins of C-1201 include SPI and the UART. You can connect C-1201 based on the I/O interface used by the DUT is SPI or UART. Then connect the USB port next to the C-1201 and the USB port on the rear of the C-3200. The C-3200 controls the C-1201 through the USB port on the rear panel. Connect the I port of the DUT and the I port of the C-3200 on the front panel, thus completing the test connection. Next, the introduction of functions. Please complete the C-3200 network connection and settings first. If it has not done so, please refer to the second video. Connect the C-3200 with the PC. After the connection is complete, execute LoRa software. After entering the program, click DUT Transmitter Test to start setting. LoRa settings include frequency, spread factor, bandwidth, coding rate, preamble length, and on or off of IQ invert, implicit header, and payload CRC. In a data format setting, you can set symbol format, Gaussian filter on/off, and its bandwidth time product, and number of symbol period, RBW and IFBW. The IFBW must be wider than the received signal's bandwidth. The bandwidth in the LoRa settings is 125 kHz. So, the IFBW here is 300 kHz. The RBW setting will affect the spectrum shape and sweep time displayed in the frequency domain results. The larger the RBW, the more circular spectrum shape and the faster sweep time. Trigger setting is to set the conditions of the captured signal, including trigger level, delay time, and trigger mode. After completing the settings, click Trigger Start to start the measurement. In LoRa Packet Editor, you can set the payload length and edit the payload data content. When editing, you can also arbitrarily choose to enter it in the hex or ASCII field, and the corresponding ASCII or hex code will be automatically displayed in the other field immediately. DUT transmitter output parameters can be set here, including PA settings, transmitter power, and transmit frequency. Among them, DUT frequency represents the actual frequency of the DUT transmitted signal, and FEI, frequency error indicator, shows the error of the DUT frequency. Click Check FEI to perform a DUT frequency measurement. Users can use the FEI value to check whether the frequency accuracy of the DUT transmitted signal is within the specifications, and even to correct the frequency of the DUT to improve frequency accuracy and ensure communications quality. The following is the number of repeated transmissions of the packet and the interval of each transmission. Click Start to start the test. The measurement result includes the modulation signal of the time domain. This result is very important and helpful. You can check whether the chirp spread spectrum modulation is normal. Frequency domain measurement result can check whether the RF performance such as frequency, amplitude, etc. is normal. The received data and the related LoRa parameters will be displayed here, such as bandwidth, TOA, time on air, FEI, frequency error indicator, symbol rate, DUT transmitting power. The test result can be exported in PDF or BMP format. This video ends here. Please continue to watch other videos. Thank you.